midpoint, or the term midpoint, is the center, okay? So whenever you think midpoint, think center of something, okay? If you were here in 6th grade, you might have learned questions like, what is in the middle or the center of 8 and 10? Or what is halfway between 12 and 15? If you were asked those questions, the way you found out that information was to find the average, AGE, of those numbers. The average. So to find the average of two things, you add them together and divide by 2. You'd come up with a 9 here, right? And I could draw a number line too, or a ruler even, and I could say, what is in the middle of 8 and 10? Well, you guys can clearly see that it's a 9. Okay, again, an easy thing. Stay with me, Philip. I know this isn't exciting stuff. But 12 and 15, change my mind. 12 and 15, so here's 12, here's 15. It's not quite as obvious. Okay, you'd be like, well, it's somewhere between 13 and 14. And you're exactly right. 12 plus 15 divided by 2, so that's 27 divided by 2, which is what, 13 and a half? That would be the midpoint. Okay, I'm done bugging you. That would be the midpoint, or the halfway point between the numbers that I just gave you. All right? The midpoint formula helps us to find the halfway point between 2 points. Okay, now we're going to get into the x's and the y's of the thing. So the definition is the midpoint formula finds a point on a coordinate, and I'm just going to include that plane, that's halfway between the two. Okay, so that's midpoint formula. They actually have it sketched on that little notebook that is important points for notes on the top of page 478. The coordinates of the midpoint of a segment are the average. Okay, so here's how you do it. The midpoint between any 2 points is the average of the sum of the x's for the x value and the average of the sum of the y's for the y value. Okay, so this is written algebraically using letters, but don't get scared about this. This is not hard to do. So what if I said to you, find the midpoint between, I'm going to give you -1, 3, and 3, 1. Okay, the midpoint. So everybody should be staying with me on this assignment, or on this lesson, because I don't want to hear later that you don't get it. Midpoint between the two. So let's call this the first set of points, and we'll call this the second, which I've been calling sub 1 and sub 2. That's the terminology you'll use. So, the two x's added together, -1 and 3, would you agree? The result of this is going to be your x value. The sum of the y's added together, divided by 2. That will give you the y value. Okay, so this gives you the x value of the midpoint. That gives you the y value of the midpoint. So we just did that right here. I took the x's, I'm adding them together and dividing by 2. And next I'm going to take my y's, right there. add them together, and divide by 2. So my y is whatever the result of negative 2 divided by 2 is. Would you agree it's negative 1 for my x? My y is whatever 4 divided by 2 is, which is a 2. Okay? So, to find the midpoints, we used the simple items that they gave us, here and found the information out. So the midpoints between this and this is negative 1, 2. Okay? Negative 1, 2. Sometimes it's obvious and you could see it on a graph. Other times it's not quite as obvious. If I were to graph this out right now, this first point, negative 1, 1, 2, 3 is here. So I'm going to call that point 1. And the second point, 1, 2, 3. I'm trying to be as even as possible. That's point 2. The midpoint is, they're saying negative 1, 2. Well, that ain't right. No, that's a positive 2. That's a positive 1. That's a positive 1. 1, thank you. 1, 2. That's your midpoint. Sorry, guys. Positive 2, positive 1. There's your midpoint. Okay, you can see it on the graph. That's not hard to see. They're not always this easy, but that is the midpoint. Let's try example 3. This is on page 478. Find the midpoint of a segment with endpoints 3, 8 and 9, negative 9, negative 4. They're asking you the same exact thing, only they're just adding a little detail. Find the midpoint of this line who is at 3, 8 and 9, 4 as their endpoint. So I want to know the midpoint of that. If I wanted to look at this and say what was the midpoint of these points, that's the same question. They're not asking anything different. Okay, rather than draw it out, we're going to use the midpoint formula. To solve for the midpoint's x value, you add together the x's and divide by 2. To solve for the midpoint's y value, you add the y's and divide by 2. So it's going to look something like this. 3 plus a negative 9 divided by 2. 9, 8, 7, 6. So am I right in saying it's negative 6 halves? Lord willing, right? So the x's value is negative 3. Okay? Plugged in the values from the x's. Okay? X, X. Combined the x's, divide by 2, and got my x value of the midpoint. The y's, y1, 8, y2, negative 4, divided by 2. So I have 4 over 2, which is 2. Everybody see that? So this is the x value's midpoint. That is the y value's midpoint. So the midpoint between these 2 points is that location on the coordinate plane. Same thing over and over and over. Okay? Let's look over at the guided practice. Go with me to the guided practice. It's on page 479. Number 4, to be specific, says find the midpoint of line PQ. Okay, to find the midpoint of this line, I need to find the coordinates of the ends. Okay, PQ. You guys can see it. Looks like the first point is negative 1, negative 1. What's the second point? Can anybody see where Q sits? Rachel, do you see where Q sits there? 479 now. We've moved on to the guided practice. 479, number 4. We're looking for the location of point Q.
2-4.
She's right. Okay, so the question they ask is, what is midpoint of this line? So P lies here, Q lies here. I'm obviously not graphing it. We want to know what the midpoint is. That's the question. To find the midpoint using the points they've given us, use the formula, which is the sum of the x values divided by 2. That will be the x location, and the sum of the y values divided by 2. That will be the y location of the midpoint. X values, are they negative 1 and 2? The sum of negative 1 and 2 is what? Positive 1. Positive 1 divided by 2 is a half, isn't it? So just leave it that way. Okay, this is 1 over 2, which we're just going to leave it. That is the x value of the midpoint. The y's, okay, and just to quickly draw your attention again, this, the first x, that, the second x, add them together, divide by 2. The y's, y1 added to y2. Looks like 3 over 2, otherwise known as 1 1/2. If you leave it as 3/2, I'm okay with it. Okay, but if you convert it to that, I also will know what you mean, okay? So the midpoint is 1/2, 3/2. Same thing over and over and over. Okay, all we've done today is the same thing over and over. We've done 3 samples, all identical. The last thing is example 4. Do you guys remember the term slope from a few chapters ago? The way I defined it for you was the change in the y coordinates divided by the change in the x coordinates. So take, for example, consider this that I'm giving you right now. Negative 1, 1, 2, 3. Negative 1, 3. And that will be 3, 1. Okay? If I wanted to find the slope of this line, I can simply subtract the y values and divide it by the subtraction difference of the x values. It might look like this. This is how I tried to teach you guys to do it. Don't know how you guys ended up liking it, but these are the x's, these are the y's. If you subtract the y values on the top, 3 minus 1, I subtract it in this direction, which means I have to do the same here. For the x's, negative 1 minus 3. So the top is the change in the y's, otherwise known as the difference. The bottom is the change in the x's. The result on the top is 2. The result on the bottom is negative 4. In reduced form, that is negative 1/2. So the slope, my friends, is negative 1/2. And you should be able to recognize that this is a negative if you remember. Downhill from left to right is always negative. So for every move down 1, the line moves 2 to the right. For every move down 1, the line moves 2 to the right. And that can help me also draw my graph if I wanted to. But let's use their example. Okay, this was mine. Let's use their sample. Find the slope of a line that passes through 3, 7, and 8, negative 3. I kind of like to stack them because that's just how I do it. I don't care how you do it. You do it whatever way is fitting for you. The change in y, 7 minus a negative 3. The change in x, 3 minus 8. 7 minus a negative 3 is what, folks? Thank you. 3 minus 8, did you come up with a negative 5? Awesome. The result here is a negative 2. Therefore, your slope is a negative 2. Okay, we've already done this chapters ago, but they're bringing it back to the table. Let's do one more, just like it, checkpoint 6, and this is the last thing I'll leave you with. I've given you 3 examples of what you've learned today. Find the slope of the line through 2, 7, and negative 3, 5. Did everybody write that down in their notes? Okay, let's subtract. Here's your y's, here's your x's. I'm going to go this way. 7 minus 5. Since I went that way here, I have to do the same direction here. Okay? The result of 7 minus 5 is 2. The result of 2 minus a negative 3 is 5. Therefore, the slope of a line that has these 2 points is 2/5. Okay? So there were 3 nice examples of how you did slope there. All together we did. There was my first example, the one I sketched for you. There was the second example from the top of page 478 in your book. And the third and final sample out of your checkpoint.